Going to move on to our next packet. Now, if you remember, in the first ever video I did, I gave a bit of a background of why folks take chemistry, and it's a prereq for pretty much everything. And the reason it's a prereq for everything is because we teach you not chemistry, but problem-solving skills. And it turns out that chemistry is the best place to learn these skills. All right, so this next packet is all about those problem-solving skills. So dimensional analysis, conversion factors, sometimes called, that's your tool set, okay? This is what you need to take forward. So in many ways, this next packet is the most important packet of the semester, okay? So let's get into it. What I'm going to do, there are several parts, and they're kind of common sense, okay? If you do it with a common sense example, and I'll choose some eggs, okay? So I'll run through the whole thing with eggs, and then we'll switch the script and do things like atoms and molecules and weird chemistry things. But the bottom line is this: if you can do the eggs example, eggs later is atoms, right? So just always come back to the eggs example just to see, where this thing kind of originates, okay? So conversions, let's talk about that. So you do conversions every day. You do them in the supermarket all the time, Apples, $4 per pound. How many pounds can I get for $12? That kind of thing, right? So simple supermarket math in your head. All we're going to do is just formalize it, put it down on a piece of paper mathematically, and then once you understand the math behind it, even the easier ones, you can apply that same exact procedure to the harder examples, okay? All right, so we do simple conversions on a daily basis. For example, how many eggs in a dozen eggs? Well, obviously 12, right? So that's no surprise. 12 eggs in a dozen eggs, yeah? Now, if you look in the back of your textbook, if you have a textbook, okay? If you look in the back cover probably, you'll find a bunch of things like this, okay? So we say in words, well, there's 12 eggs in a dozen, right? We write that as a conversion identity, okay? And we need these relationships. So this is a relationship. And you can have a relationship between anything and anything if, you think about it, right? So 1 dozen eggs is 12 eggs. A dozen donuts is 12 donuts, right? So it's an identity. Later on, we'll turn this into a fraction, but you need that relationship to do a conversion. That's the key thing. Okay, now be careful, a little bit of fine print. Remember, when we talk about significant figures, if something is measured, it has significant figures. If something is exact, it has an infinite number of significant figures, or in other words, we just ignore them, right? Is this an exact measurement? Are there 11.9743 eggs in a dozen eggs? No, there's exactly 12, right? So a dozen is defined as 12. So this one, when we look at the question and say, well, what has the lowest number of significant figure? It's neither of these, okay? Neither of these come into our discussion when we talk about significant figures because it's an exact relationship. If it was measured, like, for example, kilograms to pounds, which we'll do later, yes, we'll use the significant figures from the relationship, okay? But if it's exact, we don't, okay? So is the above identity exact or measured? It's exact, okay? So not affect sig fig, okay? So exact relationships don't affect sig figs, as we saw before. All right, so moving on now. So what I want you guys to do, and pause me in a second and then try this, okay? What I want you to do is work out, just using your kind of common sense, and we'll convert common sense to chemistry math in a moment, how many eggs are in 42 dozen eggs? That's all I want you to do, okay? So pause. How many eggs in 42 dozen eggs? All right, you're back. So hopefully you got 504 eggs, fantastic, right? But let me show you how you do that with chemistry, right? We start with 42 dozen eggs. That's our so-called given quantity. So we convert from something to something, the number of single eggs over here, right? This is going to be our answer. And what do? Well, there's our relationship. We just turn this into a fraction. Now you said to yourself, oh, it's 42 times 12. Well, actually, it wasn't 42 times 12. That would have got you to 504, but what about the unit, okay? So what we're going to do, we're going to turn this thing into a fraction. Maybe you've seen this before. The dozen eggs is going to cancel as a unit. 1 dozen goes on the bottom. 12 eggs is a dozen. So you set up a fraction with what you're getting rid of, if you like, or converting from on the bottom, what you want to keep on top. That then cancels. So what you actually did, it wasn't 42 times 12, it was 42 dozen eggs times 12 eggs divided by 1 dozen eggs. Then the units cancel. Remember, good thing in chemistry, if the units don't cancel, it's probably wrong, okay? And that gives you 504 eggs, okay? If you're a bit type A like me, this conversion factor has an infinite number of sig figs because it's a definition. This has 2 significant figures, so you know that's 4 out of 5 right now. What would that really be? It would be 5.0 times 10 to the 2 eggs. It's 500 eggs to 2 significant figures. 504 to 2 significant figures is 500, right? 2 significant figures for 500. We saw that trick before, use scientific notation. That's just a minor thing. Okay. All right, so that's pretty neat. So if you look in the back of the book, loads and loads of conversion factors, okay, loads of them, all right. Again, you can convert anything to anything, really. If you have a conversion factor, you need a conversion factor, but there's so many out there. You can even make up your own. We'll do one of those in a moment, okay. So here they are. Here's a few to get started. So obviously there's 2 versions. If I do this, right, there's one on top or the other one on top. It depends on the kind of the conversion you want to do. So I can go ounces to pounds or pounds to ounces, and I'll choose the correct kind of top and bottom for my fraction based on where I want to go, and we'll see that as we go through, okay? So what I want you to do, I'll maybe do the first one with you, okay? So if I want to have 1 inch for 2.54 centimeters, that will get me from centimeters to inches. Remember, the thing we keep's on top, the thing that cancels is on the bottom, right? What would the other one be? Pause for 1 second. The other one would be 2.54 centimeters is 1 inch. Fair enough, right? That would get me from inches to centimeters. So that conversion factor, you can write it in 2 different ways, depending what you want to convert to. Okay, is it exact? Yes or no? Well, this one has a little bit of an asterisk, and we'll actually come back to it. Okay. Generally speaking, though, if you think about it, things in the same family group, you know, ounces in a pound, it's 16, right? It's by definition, so that's going to be exact. So things in the same family, imperial or metric, if you like, if they're both in that same family, it's going to be exact. But if I'm going between families, it's like getting the kilogram from Paris, dropping it on a bathroom scale, and that's measured at that point, so they're not defined in terms of each other. So generally speaking, things like this will be no, because they're between family units. Now you may have given yourself an answer here. Okay, we're going to come back to it, right, because there's some fine print, but that should be no, but we'll write the answer in a moment. Okay, so let's do this one. Kilograms and pounds. So 1 kilogram is 2.205 pounds. 2.205 pounds is 1 kilogram. Fantastic, okay. That one would be pounds to kilograms. This one will be kilograms to pounds. All right. This one, same family group. Centimeters and meters are the same SI unit, so that's yes, it is exact. Okay. There's 1 meter for 100 centimeters and 100 centimeters for 1 meter. All right. If it's making sense, try the next one. Feet and inches. Okay. All right. Do you get it? Is it exact? Yes, because they're the same family. It's exactly 12 inches in a foot by definition. All right. Okay. So 1 foot is 12 inches. 12 inches is 1 foot. Okay. Fair enough. Now, if you've got the way of it all, okay, feel free to try and think up 3 more conversion factors. Think about a kitchen, think about weighing things, think about measuring things. Any relationship you can think of, you can write it down, okay? And you can make the conversion factors. If you need to, feel free to peek in the back of the book, okay? But you can probably just come off with things right off the top of your head. Think about time for a second. Oh, no pun intended. 1 minute equals 60 seconds, right? Fair enough. Is that exact? Yes. Now we've, have a definition of the second from the ground up. That's an exact relationship, so yes. 1 minute, 60 seconds. 60 seconds is 1 minute. Okay. You got any other good ones? How about, let's think. What have I got on my list here? Oh, I didn't fill anything in on my list. Hey, I was at the gas station the other day, right? And 1 gallon of gas was $1.85. 8E49. Okay. I wasn't Indiana, it was cheaper. All right, so what have I got? 1 gallon, 184.9, and then 184.9 is 1 gallon. Is that exact, yes or no? Well, it depends a little bit on where you do the measuring. If you do the measuring in the Mobile corporate office, how much can we get them for this week? Oh, let's pick a number out of the air. What about $184.9 per gallon? Okay, so when we do a definition back at HQ, that's exact. But when you put the gas in your gas tank, you're actually measuring, aren't you? Okay, you spill it a little bit, maybe it doesn't exactly record how much you put in there. And at the point of sale, it's a no, right? Okay. All right, another good one. If I go with pints and gallons, right? 1 gallon is 8 pints. Fair enough. That's in the same family, so that's a yes. Oh, that's a yes. Okay, so 1 gallon per 8 pints. 8 pints per 1 gallon. Those are US pints. Well, it doesn't actually matter if you're within the same family. If it's English or American, doesn't matter, as long as you kind of say that's English, that's American, whichever. Okay. This last one, weird picture, right? That's a drunk guy, right? So 1 drunk guy equals, I'm going to say 8 beers. You can convert anything to anything if you've got a relationship. 1 drunk guy is 8 beers. This will really help us with party planning later. And 8 beers is 1 drunk guy. Exact? Well, obviously no. Size of the person affects it. Mental state of the person affects it. They'll just break up with my girlfriend. Yeah, okay. I won't go on, right? Okay, so there we go. So those are some conversion factors, and yes or no whether they're exact. Remember, generally speaking, they're exact if they're in the same family, imperial or metric, but between families, generally not. One weird exception is here, which we'll talk about in a second. Okay. Now, how do you know which version, so which of those 2 fractions to use? So if I have 1 inch equals 2.54 centimeters, right? Which of the 2 fractions do I use, right, to convert? Well, as we saw with the egg example, and we can always go back and look at it, right? Let's have a look at the egg example. What you're converting from, I'm coming from dozens, has to cancel on the bottom, right? So the thing I'm getting rid of or converting from goes on the bottom. What I keep and end up with stays on top, okay? So I like to think about it in one of 2 ways, because this is what's called complementary learning. Complementary learning is like glass half full, glass half empty. You can either remember what you're getting rid of on the bottom, or you can remember what you're keeping is on the top. I prefer to think about what I'm getting rid of is on the bottom, because I get that nice diagonal cancelling, right? So that diagonal cancelling is a nice image in your head, right? So I'm going to write that. Unit to be converted from on bottom. That's the denominator of the fraction. Okay, and I got, it cancels diagonally if you remember, with the thing you're converting from. So that's a nice way to think about it. So then you choose the right fraction. So that's an easy way to choose the right fraction. Okay. Now for non-exact relationships, so if we go back and look at our table there. Okay. So in this one, for example, 1 kilogram is 2.205 pounds. Right, that's between family classes. So 1 kilogram equals 2.205 pounds. How many sig figs are in that measurement? Well, here we got 1, 2, 3, 4, right? Here you think, oh, there's only 1. Wait a minute, that makes no sense. In the back of the book, 1 something is something with lots of digits, right? It turns out this second one is measured, and this first one is exact. It's like you're getting the official kilogram from Paris, sticking it on a bathroom scale and recording it, right? So the sig figs are in the second number always, right? So the one with the most digits is measured, the one with just a 1 is assumed to be exact, because think about it, everything would have 1 significant figure if this were true as a measured, right? So for non-exact quantities, how many sig figs are implied? Those in second value. Okay, and here it's 1, 2, 3, 4. 4 here, right? So in there it's 4. Okay. Now, what I want you to do, and remember the given quantity is always measured, right? Okay. So what we're going to do in this next example is use this relationship to convert from inches to centimeters. Okay, so give you a second, work it out. All right. All right, what goes on the bottom? 1 inch, 2.54 centimeters. That's from our previous page and above, right? All right. Cancels. What do we get? Let's bang it in the calculator. Now, my advice is just, you know, put it in the calculator and just write down everything that comes out, right? 30.48 centimeters. That unit remains, okay? Now, here's the $64,000 question, okay? Here's a $64,000 question. Is it 4 significant figures or is it 3? And it goes back to that question here. Is this exact, yes or no? If this is exact, then we forget about sig figs, and that's 4, right? We use 4. However, if that's, like we said before, between classes, it's measured, right? Okay, but here's the thing. Before about 1952, it was measured, right? After 1952, it was defined as exact. Okay, so it's actually a yes. It shouldn't be a yes, but it is because of something that happened in world history. And for a little bit of extra credit, you're going to tell me. Okay, so let's just jump ahead to the extra credit. Type this one up, send it me as an email attachment, right? So I really don't like this in the book because it's non-consistent, right? There's a special story that's around centimeters and inches, right? So Dr. Mills gets very cranky with the text as it says, if you look in the back of the book, 1 inch is 2.54 centimeters exactly, and it is an exact relationship, but it shouldn't be because it's between families, right? Okay, what's the source of my confusion? Okay, that's your 100 words typed out. Okay, do a search for international inch. There's a whole story behind why inches are defined in terms of centimeters. Okay, all right, so now because the inch and the centimeter are exact, this is exact, this is significant figures infinite, forget about it, so it's 4, so that's right. Before 1952, that would have been 30.5, right, but it's not, okay. That's an exact relationship. So weird as it is, it's true. Okay, now generically speaking, we start with a given quantity, right? Inches here, right? So we have a given unit. We're talking about dimensional analysis now, right? And we also kind of put it over 1. Maybe you've done those train track things in high school or something. That's fine, you can still do that. But I like to say, hey, if it's on top, put a 1 underneath, all right? And then the fraction, I have the given unit underneath, inches and inches, right? So it cancels, right? And then the desired unit up here, and it doesn't cancel. I want to keep centimeters, right? And I get desired. So that's your dimensional analysis, right? The thing at the top stays, the thing at the bottom cancels. All right, and we're going to set these up the same every time. The thing we want to convert from is on the bottom, the thing we want to keep is on top. Okay. All right. Now, let's do some conversions like for real, right? So this is where the fun starts, okay? Now, if you feel confident, obviously I'm going to go through it, right? But if you feel confident, just give it a shot, right? Just give it a shot, and we can come back and check my answers in a second. If not, you know, maybe. If you're not maybe so confident, what should we do a couple, then pause it, right? Okay, so let's take a look. So 5.51 centimeters to meters. 5.51 centimeters is where I start, right? Now I know there's 100 centimeters in 1 meter. Put that through the calculator. Now, again, it's probably going to be below 10 to the minus 1. So that's going to be 5.51 times, let's make sure I get it right, 10 to the minus 2 meters. All right. Okay. Next one, ounces to pounds. Note, that's 23.0, so that's 3 sig figs. Oh, that one there, that's exact, that's 3, so that's 3. Okay. Ounces. All right. What goes on the bottom? Ounces to pounds. 16 ounces or 1 pound. I think we know that. All right. Ounces cancels. Remember to show the work. Okay. A quick aside here. When I grade these for your quizzes and exams, I give most of the points for work. I want to see how you do it, okay? And then maybe 10% of the points will actually be the answer itself, okay? So 23 times 1 divided by 16, 3 sig figs, that's exact. What do we get? 1.44 pound. Okay. All right, now the first two, maybe we knew them, right? This one definitely in the back of the book, 1 pound is 16 ounces. Now here, if you look in the back of the book, and you can try, there is no conversion nanometers to meters, okay? And I'm going to show you on the side, okay? So 1 nanometer, if you remember what nano was, that's 1 times 10 to the minus 9, right? So when you have decimal prefixes, you actually make your own conversion factor. So nano is 10 to the minus 9. I'm just going to swap the number for the letter. You've seen that before. Okay, so I swapped nano for 10 to the minus 9. I've made my own conversion factor, nanometers to meters, right? So let's do that. So 50.0 nanometers. Maybe we measure that with an STM machine. What goes on the bottom? Careful, nanometers. 1 nanometer is a billionth of a meter. What do we get? That's cancelling. 3 sig figs, that's exact, that's 3 sig figs. Scientific notation, minus 8. 5.00 times 10 to the minus 8. Fair enough. Now, because inches and centimeters are exact, every measurement is exact because you just scale up 1,000 centimeters. Sorry, 100 centimeters is a meter, 1,000 meters is a kilometer, okay? So, whenever you have some kind of length, it's all going to be limited by the given quantity. So 3 sig figs in the answer here, right? 3.56 miles. Now, if you look in the back of the book, 1 mile is, make sure I get this right. Well, actually I did the other one, okay? I did on my notes here. You can do either 1 kilometer is so many miles or 1 mile is so many kilometers. It's 0.62157 miles. Double check that, look in the back of your book, or look it out on the YouTube or something, all right, or the Google, right? 10.6 kilometers. All right. All right. Inches to centimeters, again, it's an exact converter, but so the sig figs are in here. Now, if you think, this is a bit of a philosophical point, right? If you think about it, you never want your conversion fraction or identity to limit the accuracy of your answer. So 99 times out of 100, the sig figs are actually in the given quantity, and that's always been true so far. So 3 there, 3 there, 3 there, 3 there, 3, 3, 3, 3. Here we're going to have 3, here we're going to have 3, they all seem to be 3, but generally speaking, whatever the sig figs are in the question, that's the same as in the answer. Okay, so here, inches to centimeters, 45.7 inches. 1 inch is 2.54 centimeters exactly nowadays. Show me the work. What do we get there? 116. 3 sig figs. If it's in the 100, you don't need scientific notation. Okay, remember what we said? Up to around 100.1, it's okay for a regular number. 220 pounds to kilograms. Well, 2.205 pounds is 1 kilogram. Now, this is going to be significant because it's between classes, between families if you like, and it's not length. So 1, 2, 3, 4 here, but 3 there, okay? As normal, this limits, right? Turns out to be 99.8, looks like. All right. Fair enough. Now, this last one, remember we can turn anything to anything. We got 20 beers. How many guys can I get drunk for 20 beers? This is theoretical. 20 beers. What was my conversion factor? 8 beers is 1 drunk guy. Do that math, right? 20 divided by, oh, I should be able to do that by some. Okay, 20 divided by 8. 2.5. 2 sig figs. That's just for fun, right? That wouldn't be on a test, but you get the idea. The point is that you can convert anything to anything with the identity. Okay, so there we go. Now these are very important to practice, okay? So I super recommend you practice, 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 and do what we call the single conversion factor identity, single link in the chain, I like to call that. Get comfortable with that before you move on to the longer ones, which we'll get to next. All right. Okay, talking of which, here we are. All right. So I've got about 3 minutes left, and this is probably a nice place just to pause briefly. I'll just add the two videos together. Okay, well, I'm going to stop now and come straight back. Okay, see you in a minute. Okay, so we're back. Now, what happens when you have a more kind of elaborate question, like convert 55 centimeters to feet? And you think to yourself, oh, we'll look in the data sheet, I'll look in the back of the book, find the centimeters to feet conversion, and we're good, right? Try it. There is no centimeters to feet conversion. It's kind of like you've got to plan your journey a little bit. So if you think about it, if I start at centimeters and I want to end up at feet, what can I go through? What links them together? Centimeters to, inches to feet. And I like to think of these as links in the chain, okay? So to be honest, planning the journey is all about the planning, all right? Does that make sense? If I want to get from A to B, it's all about planning the journey, all right? So in the first step, I'm going to go centimeters to inches with a conversion fraction. And then in the second leg of the journey, I'll do inches to feet. You know, you can either drive directly to Chicago, that's one link in the chain like we've just been doing, or you can stop in Bolingbroke for a hot dog and then go to Chicago, right? That's two links in the chain. You both of them take you to Chicago. It doesn't matter how many stops you make along the way, you eventually get there. Okay, so our journey, the first leg, centimeters to inches. Well, I want to put centimeters on the bottom. 2.54 centimeters is 1 inch. If I work that out and pressed equals, I get an answer in inches, but I don't want an answer in inches. I'm not going to press equals, right? I'm going to go inches now to feet. 12 inches is 1 foot. And you see what happens? We get this kind of lovely diagonal cancelling, right? That's why I like to think about diagonal cancelling. So this cancels, leaves this cancels, leaves that. All right, how would you do this on the calculator? You do 55 times 1 times 1 equals some number, right? Let's actually do that. 55 times 1 foot is 55 feet, right? 55, unit cancelled, times 1, unit cancelled, times 1 foot, 55 feet, over 2.54 times 12, 2.54 times 12, 30.48. Okay, so work out the tops, work out the bottoms, and when you got these two numbers, just divide them. Divide those out, what you get? Why don't you just try it? 2 sig figs, 1.8 feet. Also think about how reasonable is your answer, right? Is your answer reasonable? 55 centimeters is about this much, right? So is 1.8 feet, so that makes sense, okay. All right, so the bottom line is this. You can link as many of these conversion fractions together as you need to get from A to B. Some journeys are more efficient than others, some are longer. It doesn't matter how many steps you take, okay, how many links are in the chain. Okay, so what I want you guys to do is pause for a second, all right, pause for a second, and just try and work these out. Plan a journey, then kind of crank the handle, okay? All right, I'll come back in a second. All right, pause. All right, so this first one, ounces to grams, I'm gonna go ounces to pounds, pounds to kilograms, kilograms to grams. That's just me, right? You got to assume, although there is an ounces to grams probably converter in the back of the book, it won't be on the data sheet, okay? So 4.00 ounces times 16 ounces is 1 pound times, so if you carry, pounds now, 2.205 pounds is 1 kilogram. And then 1 kilogram, hopefully kilo, 1,000 grams, right? Work out the tops, work out the bottoms. Hopefully you get an answer of 113 grams, 3 sig figs. All right. Next one, 1.68 meters to inches. Well, let's plan a journey. Meters, what can we do here? To centimeters to inches, that's what I like. You might do meters to yards to inches perhaps, okay? Oh, here's a little trick, okay? Now, when I give you these on a test, I'm going to give you a data sheet with these conversion factors, right? You don't have to memorize conversion factors apart from SI prefix ones, right? So a billion nanometers is 1 meter, right? Okay, we did that one earlier, right? So you can work those out on the fly, yeah? But the others you would be given. So back to my point, you don't have to kind of reinvent the wheel. If you find your unit in the data sheet, just look for the conversion factor with that unit and it will kind of help you plan the journey. If you're having a problem planning the journey, I only give you the conversion factors you need. So the availability of conversion factors will kind of lead you in the right direction, right? So here, meters to centimeters, hopefully you know that one. 1 meter is 100 centimeters, right? Times 2.54 centimeters is 1 inch. What do we get? 66.1 inches. That's exact, 3 sig figs. All right. Last one, let's do a plan. Kilometers, I like kilometers to meters, to centimeters, to inches, to feet. Why not be elaborate, right? So 5.8 kilometers times 1 kilometer, hopefully you know is 1,000 meters, times 1 meter is 100 centimeters, times 2.54 centimeters is 1 inch, times 12 inches, 1 foot. What do I get? 2 sig figs, 1.9 times 10 to the 4th, 19,000 feet. Does that make sense? Yeah, it's 6 kilometers, right? It's like 4 miles, right? So it's a lot of feet. Okay, oh, sorry, move that up. There it is. Okay, so again, once you've mastered the single conversion chain things, right? Make longer chains. Okay, practice, practice, practice. All right. Now, question of the week. Oh, let's call this extra credit homework, right? If you do this by the to-do date, which I'll probably set for Tuesday, right? Okay, so check, double check the discussion area, right, where this is. Okay, what I want to do is find out how many atoms end to end would be from here to Chicago, right? So really I'm converting 40 miles to atoms, right? Okay, now I'm going to help you out a little bit because I'm going to help you plan the journey, right? So down here you're going to start with 40 miles, right? And my honest advice is if you want to do like you can make a table in Word and kind of make it like one of those train track things if you want to, but this works better with PDF, okay? All right, so if you're able to fill it out by hand and do a PDF back, that's better, but I'll accept Word or PDF. All right, so basically I'm going to go miles to atoms, right? You're going to start with a conversion factor of miles. 1 mile equals, and I got a list here, conversion factor, right? 5,280 feet. So that gets me from miles to feet, right? And 1 foot equals 12 inches. So I can go miles to feet, feet to inches, fair enough, right? And then, hey, we've got to cross over to the metric system at some point because we want to get to nanometers to atoms, right? So 1 inch equals 2.54 centimeters, fair enough. Converting centimeters to nanometers is tricky, so it's better just to go back briefly to meters. 1 meter is 100 centimeters. And then, once you got meters, 1 nanometer, as we saw earlier, 1 times 10 to the minus 9 meters. And we're nearly there, so we can convert just by putting these into a chain, miles all the way down to nanometers. And the last conversion factor is weird, right? An atom's width is 0.15 nanometers. So 1 atom, and I can work out the number of atoms at the end of the day, 0.15 nanometers. So put all those in the chain. It's going to be a lot of atoms from here to Chicago, right? Okay. If you give me that by, let's just say, you know, Tuesday night, we'll give you some extra credit. All right. Now, this is an exam question. Okay, this is an exam question. The answers are given, so I'm going to kind of set it for you guys just for practice. All right. I'll walk you through it a little bit though, right? So the mass of the wire let's just read the question. So copper wire weighs 2 pounds, right? And has this diameter, radius, right? And this is a good question because it combines so many things from this and the previous packet, okay? So determine the wire's mass, volume, and length in the unit specified. Kilograms, right? So that's easy, yeah, because you've got 2 pounds. Just turn it into kilograms. Easy peasy, right? Now, down here, volume of the wire, this is a density problem, density, mass, and volume. But remember, when we use densities, that's 8.95 grams per centimeter cubed, right? We got to use grams. So first, turn the mass of the wire into grams, and then use this density, use this mass to figure out volume. Nice and easy, right? Volume equals mass over density. All right. Length of the wire. A little bit trickier, Remember, volume equals pi r squared L for a cylinder, and a wire is a cylinder, a really long cylinder, but okay, right? Want the length, right? So length equals volume over pi r squared. Careful now. Got the diameter there. Diameter divided by 2 is radius, all right? And then that's in microns, 10 to the minus 6 meters. So you've got to convert it to centimeters. So that's a little bit more challenging. Give it a shot, right? Okay, so stop there. Hopefully that all makes sense. I'll get this up. It's Friday today. Hopefully I'll get it up today for you. And you can kind of leisurely answer this over the weekend, ready for, the extra credit. Okay, stop there. See you next time.